the star that shook the solar system, a forgotten visitor from the Stone Age. In the silent depths of interstellar space, where even light takes years to traverse the void, an unassuming stellar vagabond once brushed past our home. It arrived without warning, unseen by human eyes until long after its departure, and yet its fleeting presence may have forever altered the structure of our solar system's most remote frontier. This is the story of Scholz's star, a low-mass intruder from the galactic suburbs that may have once triggered a slow-motion cascade of icy chaos, and what its passage reveals about the fragility of cosmic balance. Hashtag Voyager's distant outposts, a perspective on the void. More than 45 years ago, humanity launched its first emissaries to the stars, Voyager 1 and Voyager 2. These twin spacecraft, each a testament to the ambitions of a young spacefaring civilization, have since traveled far beyond the planets and into interstellar space. Today, Voyager 1 is an astonishing 164.66 astronomical units (AU) from the Sun. That's roughly 24.63 billion kilometers, or more than 150 times the Earth-Sun distance. Voyager 2 follows at a still impressive 137.61 AU, or 20.59 billion kilometers, from our home star. But even these far-flung explorers have not yet reached the Oort cloud, a vast, theoretical halo of icy bodies that marks the outermost edge of our solar system. And it is within this distant realm, tens of thousands of AU away, that the ghost of an ancient encounter still lingers. Hashtag a red dot in the Stone Age sky. 70,000 years ago, when Neanderthals and early Homo sapiens shared a raw and unforgiving world, the night sky was darker, purer, and perhaps more mysterious than any modern observer can imagine. But had one of those ancient eyes looked up, they might have seen something strange, a faint red glow, slowly moving against the stars. This wasn't a planet or a comet, but a stellar visitor. A red dwarf star, faint, cool, and small by stellar standards, accompanied by a likely brown dwarf companion. Together, this binary system passed through the outer edges of our solar system, close enough to stir the icy remnants of planetary formation. Its scientific name is a mouthful, WISE J07200 3.20-084651.2. But today we know it more simply as Scholz's star, named after its discoverer, astronomer Ralph Dieter Scholz, who identified the faint object in 2013 using data from the WISE Wide Field Infrared Survey Explorer mission. Hashtag a featherlight star with a heavy impact. With a combined mass of just 0.15 solar masses, Scholz's star is a stellar lightweight, a cosmic ember compared to our Sun. Its dim light and modest size led many astronomers to believe it posed no real threat or influence during its passage. And yet there were anomalies. Although the star is currently about 22 light-years away from Earth, its motion across the sky, or more precisely, its lack of motion, raised eyebrows. Scholz's star appeared almost stationary, which strongly implied it was either coming toward the solar system or moving away from it at high speed. Spectroscopic analysis revealed the truth. Scholz's star had already come and gone, moving away on a gentle outbound arc. But just how close had it come? Hashtag turning back the clock. A journey into the past. To answer that question, scientists at the University of Rochester performed thousands of orbital simulations using precise velocity and position data. They mathematically rewound the clock, letting the star retrace its cosmic steps through space and time. The result was stunning. In 98% of the 10,000 simulations, Scholz's star passed directly through the Oort cloud, the icy borderlands of our solar system. The Oort cloud, though still theoretical in nature, is believed to form a vast spherical shell extending up to 100,000 AU from the Sun. It is the presumed nursery of long-period comets and a kind of frozen fossil record of the early solar system. When Scholz's star made its pass, it came within 52,000 AU, or 0.8 light-years, of the Sun. That's closer than any other known star has ever come. By comparison, Proxima Centauri, our nearest stellar neighbor, lies a comfortable 4.2 light-years away. Scholz's star came 5 times closer. Hashtag a cosmic intruder's signature in the sky. Despite its low mass, the idea that Scholz's star left no impact seemed increasingly unlikely. A key skeptic of that view was Carlos de la Fuente Marcos, an astronomer at the Complutense University of Madrid. Along with his team, he investigated the orbits of nearly 340 long-period and hyperbolic objects within our solar system, comets and icy bodies on steep, elongated trajectories. If the Oort cloud were uniform, these orbits should be randomly distributed across the sky. But the data told a different story. A statistically significant number of these objects pointed back to a common origin, the constellation Gemini, precisely the region of the sky where Scholz's star had passed 70,000 years ago. It was as if something or someone had stirred the hive. The conclusion was increasingly inescapable. Scholz's star had altered the orbits of these icy objects, nudging some toward the inner solar system and sending others out into the interstellar night. Some simulations now suggest the star may have passed even closer than previously thought, perhaps as close as 0.6 light-years, close enough to jostle thousands of Oort cloud objects and potentially send a few hurtling toward the inner planets. Hashtag the next stellar intrusion, Gliese 710. As Scholz's star fades into the black, another cosmic traveler is already on its way. This one, however, promises to be far more disruptive. Meet Gliese 710, a 0.6 solar mass orange dwarf star, currently 62 light-years from the Sun. Unlike Scholz's subtle brush, Gliese 710 is headed straight toward us, and its future trajectory is alarming. In 1.3 million years, it is expected to pass within 1.1 light-years of the Sun, close enough to plow through the Oort cloud with potentially devastating consequences. At that distance, Gliese 710 could trigger a cometary bombardment, sending a torrent of icy projectiles inward and dramatically increasing the chances of an Earth impact. Scientists estimate the rate of comet strikes on Earth could rise by at least 5%, possibly more. For our distant descendants, that may spell a serious planetary threat. A large enough impact could rival the Chicxulub event that helped wipe out the dinosaurs 66 million years ago. Hashtag a glimpse into the fragile future. While 1.3 million years may seem like an eternity, it is but a blink in cosmic time. And today, we have only begun to understand the delicate gravitational ballet that governs the solar system's outer regions. The story of Scholz's star is not merely a tale of ancient starlight and forgotten paths. It is a warning, a cosmic whisper that even the faintest traveler, at the right distance, can shake the architecture of worlds. But hope is not lost. With missions like DART, which successfully alter the orbit of a small asteroid by a kinetic impact, humanity has taken its first steps toward planetary defense. We are no longer blind to the night sky, nor helpless in the face of celestial threats. The stars may come and go, but now we are watching,